Welcome to Linear Algebra. In our very first video here, we'll start in a familiar place, solving linear systems. I think you'll see that you know a lot about solving linear systems already, but we'll talk about solving these systems in new and different ways. We'll start with some familiar examples. For our first example, imagine you're in physics class and you have three objects. The first object is known to have a mass of 2 kilograms, and you'd like to find the two unknown masses. You play around with a meter stick, and you produce two different ways for the scales to balance. And you make some measurements. You also know that for the masses to balance, you must have the sum of the torques on the left equal to the sum of the torques on the right, where torque, of course, the torque of an object is its mass times its distance from the balance point. This allows you to write a system of two linear equations. The first equation, coming from the balance on the left, would be 40h plus 15c is equal to 50 times 2, or 100. The second equation, coming from the balance on the right, would be 25c is equal to 25 times 2, or 50, plus 50 times h. The main idea of this chapter is solving systems of equations precisely like this one. Pause the video real quick and see if you can find a solution for C and H using methods that you've previously learned. One particularly efficient way to solve a system like this is using substitution. As you can see here, I divided the second equation by 25 on each side to produce the equation C equals 2 plus 2h. With C isolated, I substituted it back into the first equation, solve for H, and use back substitution to solve for C. We'll use similar but slightly different methods in this unit to solve similar but slightly different linear systems. Our second example comes from chemistry class. Here we're mixing some amount of toluene and nitric acid under controlled conditions in order to produce trinitrotoluene and a byproduct of water. Now, this must be under very controlled conditions, and I wouldn't recommend doing this at home because trinitrotoluene is also known as TNT. This time we know that the number of atoms of each element must be the same before and after the reaction, and that allows us to write another system of equations. Applying this idea to each individual element allows us to write 4 different equations. Analyzing the carbon, and we can conclude that 7x is equal to 7z. Looking at the hydrogen, we could say that 8x plus 1y is equal to 5z plus 2w. Looking at the nitrogen, we could say that 1y is equal to 3z. And then looking at the oxygen, we could say that 3y is equal to 6z plus w. Like the last example, we have exactly the number of equations as we have unknowns. 4 equations and 4 unknowns, x, y, z, and w. Pause the video again and see if you can find unique solutions for x, y, z, and w. Try as you might, you won't find a single solitary solution to this system of equations, unlike with the last example. And that should make some intuitive sense. If I were to find any particular ratio of x to y to z to w in this system that worked, then simply doubling or tripling the prescription should also work. I hope that this idea piques your interest because linear algebra is more than just about studying ways to solve systems of equations, but instead trying to understand why some systems of equations have exactly one solution and some might have many more. As for this problem, I think that any mixture that had 1 part toluene for 3 parts nitric acid would produce 1 part TNT and 3 parts water. To be clear, that's very different than saying x is equal to 1 and y is equal to 3 and z is equal to 1 and w is equal to 3. For I might take 100 milliliters of toluene and 300 milliliters of nitric acid, and the reaction would go according to plan. For a third example, we'll leave the fictitious classrooms and instead enter the world of social media, where you've surely seen something like this passed around. Do you know the answer? Meaning, do you know what burger plus fries times soda is equal to? Pause the video and see if you can figure it out. You might find problems like these kind of boring and trivial, and usually there's a dumb little trick where they switch from 2 fries to 1, but it's worth mentioning here. Not because we can work out the answer of the drink is equal to 10 and the burger is equal to 5 and a single fry is equal to 1, but because of this third equation that we look at here, this is the only equation we've seen so far that is actually not linear, because we have 2 of our variables, 2 of our unknowns being multiplied by each other. So these are equations, this one that I'm starring down here, hamburger plus fries times drink, that we won't study in our linear algebra course. Of course, we can work out the answer, and the question mark is simply 5 plus 1 times 10, so 15. If that last example made you a little hungry with the fictitious burgers, then this one's going to be even worse. Imagine you walk into In-N-Out Burger and you see the prices up on the menu. The cost of a double burger, which is double meat and double cheese, is $2.65. A cheeseburger is $1.75, and so on. None of those seem to satisfy your hunger, so you wish to order this hideous monstrosity over here, which is a 100 by 100 burger, which means it just has a single bun and a single piece of lettuce and tomato, but it has 100 beef patties and 100 disgusting slices of American cheese. Notice that the cost of the 100 burger is not on the menu. Can you figure out how much it would cost based off of the information already on the menu? Pause the video for a second and see if you can figure it out. A quick way to work this problem out is to look at the difference in the cost of the double and the cheeseburger. $2.65 minus $1.75 is 90 cents. And what 90 cents is going to buy you is, well, if you take a double, which is 2 patties and 2 pieces of cheese and a bun and all that stuff, and you subtract a cheeseburger, which is 1 patty, 1 piece of cheese and the bun and all that stuff, it's going to be the cost of a single patty and a single piece of cheese. So you get a single patty and a single piece of cheese. Well, it stands to reason if you were to take 99 of those, 99 times 90 cents, and add it on to the cost of a cheeseburger, you would have that disgusting looking monstrosity over there on the right-hand side. So 99 times 90 cents plus $1.75 is $90.85. If we add to that 7.5% sales, we get $97.66. Let's wrap up this video with a few important definitions about what makes a system of equations linear. After all, we can see that these systems of equations pop up all over in physics, in chemistry, or just at the In-N-Out Burger. And we're going to study them in depth in linear algebra, so we need to know exactly what they are. First, I'll define a linear combination of variables, x1, x2, up to xn, as a1, x1 plus a2, x2 plus all the way up to an, xn, where the ai's are all constants. So the ai's themselves are not variables, but they're real numbers that are just multiplied by the variables. Meanwhile, a linear equation looks like that linear combination set equal to some right-hand side, d, where that d is also a constant. And then to build from a linear equation to a system of linear equations, you just take any number of linear equations, could be 2, could be 10, and you try to satisfy them all simultaneously. And that makes a system of linear equations. I hope this video provided a small taste of the kind of things we'll be studying this year, as well as give you some idea of some of the simple prerequisite skills that you'll need to get this going.